So the word trigonometry is made of three subwords, three side measurement. So it's referring to a right angled triangle. Let's draw a right angled triangle whose one side is known and the other two sides are unknown. An angle other than the right angle is known. Here theta is known. So we make use of different trigonometric functions to find out the sides of the unknown. These trigonometric functions are sine, cosine, tangent, cosecant, secant and cotangent of some angle theta. Sine, cosine, tangent, cosecant, secant and cotangent. So let us know what these functions are. Here is a right angle triangle ABC right angled at B. Angle BCA is angle theta. Angle opposite to angle theta is AB and adjacent to it is BC, and AC is the hypotenuse. Sine function of angle theta or sine theta is the ratio of opposite side to hypotenuse of the triangle, that is AB by AC. In this case we get theta as sine inverse of opposite by hypotenuse, which we will cover in upcoming inverse trigonometric function. So similarly, cos function of an angle theta or cos theta is the ratio of adjacent side to the hypotenuse side of the triangle, and here tan theta is equals to sine of theta by cos of theta, that is opposite by adjacent side. So if one knows the sine function, then the other functions can be easily calculated. Let's see the other function, that is cosecant theta is the reciprocal of sine theta, that is hypotenuse by opposite. Secant theta is reciprocal of cos theta, that is hypotenuse by adjacent. And cotangent theta is or cot theta is reciprocal of tan theta, that is cos by sin theta, that is adjacent by opposite. So let's draw a right angle triangle with one of this is a right angle triangle with one of its sides approximately one of its angles approximately 0 degrees. Here is the triangle, such that hypotenuse is equals to adjacent and opposite side is equals to 0. So from here what we get is sin theta, that is sin 0 degrees is 0 by hypotenuse, that is 0, and we get sin theta as 0. Similarly, cos theta is 1 and tan theta is 0. So next we let's draw a isosceles right angled triangle whose two sides are equal. Right angle in the middle and hypotenuse is the opposite of that 90 degree. Here is angle theta. What we have is sin theta equals to cos theta. Why? That's because the opposite side is equal to the adjacent side, and opposite by hypotenuse would be equal to adjacent by hypotenuse. So for what will be the value of this function is, for this we have to compare the square such that the hypotenuse is, here we draw a square such that the hypotenuse is the diagonal, and from the properties of a square what we get is 2 times the angle of theta. 2 theta is equals to 90 degrees and theta is equals to 45 degrees. So from the square theorem, square of hypotenuse theorem, we get hypotenuse as under root 2 times the other two sides. Let's take the other two sides as 1, and here hypotenuse is root 2. So hence we get sine 45 degree equals to cos 45 degree, that is 1 by root 2, and tan of 45 degrees equals to 1. Here tan of 45 degrees equals to 1, as sine of 45 degree by cos of 45 degree is 1. Now let's draw a right angle triangle with other angle approximately equals to 90 degrees. Here is the triangle. They will meet somewhere far at infinite. So in this case the opposite side is approximately equal to that of the hypotenuse side, and adjacent side is nothing but 0 in front of the long sides. So here what we get is sine of 90 degrees is equals to 1. Sine 90 is 1, cos of 90 is 0, and tan of 90 is 1 by 0, that is not defined or infinite. So here I draw a table of value of trigonometric function with angle 0 degree, 45 degree and 90 degree. Now at 30 degree and 60 degree, it's experimentally proven that we can prove it easily. Sine 30 degree equals to cos 60 degree, that is 1 by 2, and sine 60 degrees equals to cos 30 degree, that is root 3 by 2. Sine 30 1 by 2, sine 60 root 3 by 2, and here tan 30 is 1 by root 3 and tan 60 is root 3 by 2. So we have covered all the angle from 0 degree to 90 degrees. trigonometric functions of theta, where theta is from 0 to 90, but theta can be less than 0 and can be more than 90. We are not going to cover this in this video. So first of all, let's be familiar with the radian. So let's draw a circle of radius r. Let's draw another radius. Here radius is L. Let's draw another this is arc length L. Here is another radius. Here the radian is angle theta such that arc length is equals to the radius. So 1 radian equals to arc length by radius. Here it's the circumference of the triangle. So to understand this, just remember that circumference of circle is 2 pi r. So what we get is 360 degree of full rotation is equals to 2 pi radians. Here is 360 degrees full rotation. For this we get 2 pi r circumference. So radius radians is 2 pi radians. That means pi radians here pi radians is equals to 180 degrees for 2 pi equals to 360, and 90 degrees, what would be 90 degrees? 90 degrees would be pi by 2 radian. Sixty degrees would be pi by 3 radian. 45 degrees is pi by 4 radian. And 30 degrees is pi by 6 radian. So 1 radian is 180 by pi degrees. Or 1 degree is pi by 180 radians. Radian symbol as C. So 50 degrees would be 50 times that of pi by 180 radians. Pi radians is 180 degrees. So what would be 1 radian? That is like 180 by pi degrees. Three times that of this 3 radians is 3 times that of 180 by pi degrees. So here we can convert radians into angle and angle into radians. Again, if one gets confused between radians and degrees, just remember one thing. 360 degrees of full circle circumference is 2 pi r, or 360 degrees is 2 pi radians. From this you can get over the confusion. So these are some of the basics of trigonometry. I will cover another functions and inverse trigonometric functions in some other classes. Till then, be safe in quarantine. Thank you.